Okay, folks, this is just going to be a quick video on the solutions to the first homework project that we had, looking at simple mechanisms and inclined planes. As you can see in the picture here, I've given you a way of looking at the forces down the plane, which is mg sine theta, and the forces normal to the plane, which is acting into the plane at 90 degrees, into the actual ramp at 90 degrees. So what I'll do is I'll go onto the next page and I'll start drawing on this diagram, just so we understand what's going on. So this is the diagram we were working on, and I will just call up our pen function so we can actually, I can actually see the damn thing, because there it is there. Okay, so we've got a 10 kilogram mass on our ramp, and we have a 20-degree slope and a 2-meter height. What is the force acting down the plane is question 1, which is this question here. So what we need to do is we need to know that from the center of gravity, the force acting down the plane is equal to mg sine theta, where m is the mass, which is in this case 10 kilograms. Gravity, we're going to say, is 10 meters per second squared, so times 10 meters per second squared, and then we times it by sine 20 degrees. Now if you put that all into your calculator and do it correctly, you will end up with a force, and we'll call it force X for acting down the plane, is equal to a value of 34.2 newtons. So 34.2 is the answer that you should get. Then they're asking for what is the force normal to the surface. Now I meant to the surface of the ramp, and I had to explain that in class, so I didn't really give you a good explanation in the question, but this is the surface we're talking about, and normal means the force that's acting in this case either straight down or straight up at 90 degrees. Okay, 90 degrees to that ramp. So in this instance, at 90 degrees to the ramp, we'll look at that there. It's going to be equal to, in this instance, mg cos, sorry, we got that wrong, we can't write, mg cos theta, which again is 10 kgs times 10 meters per second squared for the gravitational acceleration. In this case, it's cos 20 degrees. And that answer, you should have gotten a value of 94 newtons. So we've got this way acting this way, down the plane 34, and acting into the plane we have 94 newtons. So they're the two answers for 20 degrees. What is the weight of this mass? Now we've discussed this in class a lot of times. People tend to get the idea of kilograms as weight. Well, kilograms is mass. Okay, and we know the kilograms of this object on the incline is 10 kgs, and we know that force is equal to mass times acceleration. So if we say F equals m times a, mass times acceleration, we know that the mass is equal to 10, and we know the acceleration due to gravity, it's 10 kgs, and we know the acceleration due to gravity is 10 meters per second squared. 10 times 10, we end up with a weight, which is always a force in physics, of 100 newtons. Okay, then we've asked, does the ramp make us do less work? Now, like I was talking about with simple machine, an ideal simple machine, if it's got 100% efficiency, which actually never happens, but if it is an ideal machine and we've got 100% efficiency, then going from the bottom of this ramp all the way to the top, or just picking up our 10 kilograms if it was here at the bottom of the ramp at ground level, and lifting at the 2 meters is going to get you the same result. So you could take 34.2 and multiply it by the calculation for the length of the ramp, but the easiest way to work this out, of course, is to just say your weight force, which is acting down, which we know is 100 newtons, so we already worked that out. We've got to go 100 newtons and we've got to move it at 2 meters. So once you do that, you know that the calculation for the amount of work required, which is going to give you an energy, is equal to work equals force times distance. Let's say D, make it easier. Force times distance, which is equal to 100 newtons of the weight force multiplied by the 2 meters to the top of the ramp, which equals 200, and if this is in newtons and this is in meters, you get joules. Okay, so you can write that as 200J for joules. So that's your figure in joules. And does the ramp make us do less work? No, it's the same amount of work, but because you're applying only, instead of having to apply 100 newtons to get it off the ground here, if you're going vertically up, all you have to do, if you wanted to push this box up the ramp, see how I'm drawing this arrow up the ramp, I'd only have to do 34.2 newtons to push it up this way instead of 100 to go vertically. So if I'm using yet less force, and we know that work equals force times distance, and we know that the work is equal to 200 joules, then if I reduce the amount of force, I have to increase the amount of distance so that we always end up with this figure of 200. And that is why we do not do more work. We just apply less force over a greater distance. Okay? Less force means more of a distance. And that's how these simple machines make work seem like it's easier. It isn't really easier. It just means you're working for longer. But it makes it possible because you can do it with less force. And how long is the ramp? The length of the ramp is worked out using basic trigonometry, and basically what you need to do is you've got 20 degrees here. This is a right angle triangle. We know this is the hypotenuse, is what we're trying to work out. We know that this angle here, this side here is 2 meters, and we know that if we're looking at sine of 20 degrees is equal to, remember, SOHCAHTOA, SOH is sine is opposite on hypotenuse, so we end up with 2 meters over h, which is the distance of the ramp, and we change the subject of this formula so we get h by itself. Multiplying both sides by h, we'll end up with h sine 20 degrees is equal to 2 meters, and then we divide by sine 20 on both sides, we get h equals 2 meters over sine 20 degrees. And that gives us a ramp length of 5.8 meters approximately. And if I was to take that 5.8 meters and multiply it by the force acting up the down the plane, which is 34.2, you would end up with a figure that's approximately 200 as well. Not quite 200 because these were approximations, but close enough. So it's the same amount of work, just a longer distance. Now what I'm going to do for the rest of these questions is I'm just going to rub out these answers and just use the same working out to get answers for a 40-degree ramp. The only difference is that you end up with different figures because it's a steeper ramp. So you end up with a shorter. It's not letting me. Oh, here we go. We're rubbing out now. So all that happens is we end up with a shorter ramp because it's a steeper run to the top of the 2 meters. And that's the only difference really. So same working out. The amount of work is always the same because you're moving the weight through a 2 meter height. So we use 200 joules, that remains the same. Steeper ramp is the same amount of work, because the ramp doesn't change the amount of work, but because the ramp is steeper, there's just a little bit more force required, or quite a bit more force required to overcome the force acting down the ramp. So for this figure, if this is 40 degrees, what ends up happening is we use the same formula, mg sine theta, to work out the force down the ramp, but in this case it'll be 10 kilograms by 10 meters per second squared, which is gravity. That doesn't change, times, in this time, it's sine 40. Okay, so you actually end up with a force acting down the plane of 64.3 newtons. Okay, so 64.3 newtons acting this way down the plane. Okay, force normal to the surface is exactly the same working out, but instead of cos 20 degrees, we go mg cos theta, which equals 10 by 10 by cos 40 this time. So force normal to the surface is going to be 76.6 newtons acting down. The mass acts straight down, okay? It's going to always be the same, mass times gravitation, okay? So that does not change, the weight does not change. The ramp does not make us do less work. And the length of the ramp, you work it out exactly the same way, but this time your triangle, this is 90 degrees, sorry I've drawn it so badly, has a 40-degree angle. This is still 2 meters, but h is going to be shorter because it's a steeper ramp, and we end up with the same working out. H is going to be 2 over, but in this case it's going to be 2 over sine 40. So the ramp ends up being 3.1 meters. So ramp length equals 3.1 meters. And that's how you do that question. And the only other thing you needed to do was this question here, mass on a plane. They're asking for the normal force to this ramp here. And we've already talked about the normal force that acts at 90 degrees to the ramp. It's going to be mg cos theta. Okay, so that was just for that little multiple choice question at the bottom. Hope that helps. Sorry it took so long. Go over the questions again. If you have any confusion about this, you need to come and speak to me and ask for help, because that's the only way you're going to get better at this. Thanks, and I'll see you with the next homework task.